Chapter 1, Lesson 1.4, The 5 Generations of Computers. Computer historians classify every computing machine into one of 5 generations, each defined by its core switching technology. This is essential knowledge for WASSCE, BECE, and University ICT exams across West Africa and beyond. The 5 eras are vacuum tubes, transistors, integrated circuits, microprocessors, and artificial intelligence. Each generation brought dramatic improvements in speed, size, cost, and capability. First-generation computers ran from 1940 to 1956. The defining technology was the vacuum tube, a large, fragile glass component acting as an electronic switch. These machines were enormous, filling entire rooms. They consumed huge amounts of electricity, ran extremely hot, and failed constantly. ENIAC alone used 18,000 vacuum tubes, and a single failed tube crashed the entire machine. Programming required pure machine code, raw binary numbers with no programming languages at all. Key machines include ENIAC, UNIVAC I, and IBM 701. Only governments and large universities could afford them. Second-generation computers ran from 1956 to 1963. The transistor, invented at Bell Labs in 1947 by Shockley, Bardeen, and Brattain, replaced the vacuum tube entirely. This breakthrough earned them the Nobel Prize in 1956. Transistors were a tiny solid-state switch about 1 millimeter in size. Faster, cooler, more reliable, and far cheaper. Computers shrank from room-sized to desk-sized units. Assembly language replaced pure binary, making programming accessible for the first time. Large businesses and universities began adopting computers commercially. Key machines: IBM 7094, CDC 1604, IBM 1401. Third-generation computers ran from 1964 to 1971. The breakthrough was the integrated circuit, or IC, which packed multiple transistors onto a single silicon chip. Jack Kilby at Texas Instruments invented the IC in 1958, and Robert Noyce at Fairchild independently developed one in 1959. Both received credit. This dramatically reduced size and cost. High-level languages, Fortran, COBOL, and BASIC, emerged, meaning non-engineers could now program. Time-sharing also arrived, letting multiple users access one machine simultaneously. Key machines: IBM System 360 and DEC PDP-8. Fourth-generation computers run from 1971 to the present. The defining technology is the microprocessor, the complete CPU etched onto a single chip using VLSI, or very large-scale integration. Intel released the 4004 in 1971 with just 2,300 transistors. Today's Apple M4 contains 28 billion. This explosive growth is described by Moore's law, Gordon Moore's 1965 prediction that transistor count would double approximately every 2 years, a prediction that held for 60 years. This era gave us personal computers, graphical interfaces, the internet, and smartphones. Every person on Earth now carries more computing power than the Apollo moon missions. Fifth-generation computing began in the 1980s and is still evolving today. The defining characteristic is artificial intelligence and parallel processing. Unlike all previous generations, which simply executed instructions, fifth-generation machines learn from data. Neural networks, machine learning, and large language models like ChatGPT and Claude are all fifth-generation technology. Purpose-built AI chips like NVIDIA H100 and Apple's Neural Engine power these workloads. Self-driving cars are a real-world application today. Looking ahead, quantum computing may represent the transition to a sixth generation entirely. Lock in the 6 key terms: vacuum tube, first generation, glass electronic switch, hot and unreliable. Transistor, second generation, small solid-state device. IC, integrated circuit, multiple transistors on one chip, enabling high-level languages. Microprocessor, complete CPU on a single chip, powering all personal computing. VLSI, very large-scale integration, billions of transistors per chip. Moore's law, transistor count doubles every 2 years, predicted by Gordon Moore in 1965. Quiz. Quick check time for lesson 1.4. Moore's law states that transistor count doubles approximately every how often? 4 choices, read carefully before answering.